Yes, sir. Good afternoon,
हां,
sir.
गुड आफ्टरनून. चालू करायचं?
Oh,
Uh,
sir.
uh,
Yes, you can start.
हां. So yesterday we were discussing about control positioners, and there are three generations what we have seen: pneumatic, then analog, 4 to 20 milliamp means HART, foundation means a field bus, and now the control valves are on wireless also. So uh, we'll see here how it is happening here. Control working here. I2P signal coming from the loop, control loop. This is a mechanical system, flapper nozzle system, and then you can see here the control valve is getting operated. Air signal is here, and feedback, position feedback is coming. This is a basic system, pneumatic system, mechanical system, we can say. Air supply 20 psi, and this dotted portion is a wall positioner. So wall positioner technology changing. This mechanical part, whatever it is as it is. I2P is as it is. So wall positioner evolution is from pneumatic, means mechanical, to the heart communication protocol base, and then digital means field bus base, and now it is available with wireless also. So, so see here, just a minute. So this is what this is the positioner part you can see here. We are talking about this evolution of this, right? So this is the air supply. You can see this is the what link flapper nozzle system here. The flapper, this is nozzle, and through this air relay feedback comes here. Mhm. Mm. Just a minute. So you can see here the signal evolution. You can see pneumatic signal, analog signal, then feed hard signal, analog to digital, now field bus, and then wireless. So this is what evolution what we have seen. I I will skip. Sorry, huh? This is the hard signal where analog and digital both are mixed. Where the digital is a frequency based, logic one is a 1200 hertz, and logic zero is 22 hertz. So field bus, when we talk about the field bus, there are two options in the field bus. एक आता है foundation field bus and दूसरा pop field bus. So foundation field bus logo is this one. So it is available. It is a pure digital. Is a digital two-way multi-drop communication. It's like a networking. You can do the devices like the local area network. Same thing. Um, you can have these benefit: intrinsic safety available, security available, complex continuous control PID is also possible. So you see in the field, this is the line where the field bus is installed. Sorry, control is installed, and this is the positioner. This is wall from Fisher, very reputed manufacturer in the world, Fisher, and it is used for a very highly, we can say, critical applications, explosive areas also. Field bus has this is the basic for the field bus. You can see the how networking can be possible here. You can see this loop on H1 network like this. You can network like this tree type, multi drop type, and point to point also possible. Mm, mm. So these are the field bus devices shown here. Uh, mm, so basic in the field bus base control wall positioner, you can see there are three blocks, software blocks, algorithms are available in this positioner. One is a resource block, transducer block, and function blocks. So all three blocks are there inside the microprocessor of the positioner. So we'll see. Uh, Therefore, the wall is very intelligent. What we call as a wall is intelligent. It acts as a controller also. So these are the wiring details. I'm skipping this, but you see here uh, field bus and conventional wires. So in the field bus, from the junction box, normal conventionally we have this type of system. multi-pair cable like this. If you compare normal normal wiring is like this. Each transmitter has two wires in junction box, and this all devices wires are coming to the marshalling cabinet, right? And this bunch of wires then wired here in IO terminations and then goes to the controller like this. However, when we use, so what is happening here? Wiring, input output cards will be more, cables will be there, termination, intrinsic say barriers, and marshalling cabinets. So all these are required because of number of inputs are more in the plants. But when you go for field bus, means digital uh, communication protocol based your field instrumentation, then you can see the single wire for this particular area, and so hardly a few wires are coming. Like networking, we save the wire, same thing, and you can see the size of the marshalling cabinet, size of barriers requirement, size of system IO cards, size of controller reduces. So you can see these are benefits in the field bus technology. So cards are same, but you can see fewer termination, fewer intrinsic say barriers. Barriers is for hazardous area required. So requirement will be few because each cable one barrier. So naturally the cables are reducing. Reduce wiring. Junction box also reduce. Fewer termination here, and you'll get a cost saving in the wiring, IO cards, termination barriers, and marshalling cabinets by use of field bus technology. So in the field bus, there are different topologies are used for connections. There are some topography means you can say in the field bus they introduce this they call as the H1 segment, means H1 communication network, H1, this one, and one more is H2, means this side they call as H2. So for the field devices, they call as the H1 cable here, H1 communication. The whatever communication happens is called H1, and the cable coming from the card system to the junction box of this is called trunk cable, main cable, and from junction box to the devices, the cable is called spur cable. So this is a standard terminology used in the field bus, especially in the foundation field bus. Now you can see here conventional and field bus. So this is a field bus based processing automation, and this is a conventional direct wires. You can see workstation control is required. Here input output cards, and you can see individual devices wiring. It's the traditional 4 to 20 milliampere based signal. However, in the field bus, what happens? Single wire, and this is the devices are multi drops, and you get it is linked to the your DCS controller, right? So advantage is here is a one-way communication. You can say one way. If the control is also one way from output side, and this is a bidirectional communication because it's a digital signal. So if you see any field bus closed loop, how it is operating, this is a transmitter, this is a control wall. You see, this loop is here. So no need to be controlled through DCS controller. So device is here, one device is two, and you can see this PID and AO block, signal conditioning block, which earlier conventional system we use from DCS cards, DCS controller. However, inside the positioner, these blocks are there. I have shown in one of the slide the in the positioner resource block, transducer block. So these are the what blocks are there here. So FF wall positioners, these are various pictures of from different manufacturers positioners. You see here, this is from Fisher, this is from Dresser, Samsung, Smar. This yesterday we have just seen here the field bus positioner block diagram. So field bus signals is digital coming inside the communication modem. Sorry, for field bus modem, CPU, digital D2A, A2D, because it is required here. Hello, hello, hello. So block diagram of a smart full wall positioner. You can see here. Hello, hello. Input position set point input current or signal coming from the control room. Position set point. So internally, whatever we have seen in the block diagram, same PID position control, current to pressure converter is inside, pneumatic relay is inside. So all these are embedded inside the box. So position set point coming also. See here. Hello, 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 hello. Am I audible? Hello.
Yes, sir.
Am I audible? Yeah.
Yes, sir.
Okay.
You are audible, sir.
Uh, so this is the electronic block diagram of a smart pollution. So here you can see uh, main circuit board like this, display is like this, and this is output circuit board. So you have a flapper nozzle inside, the temperature sensor, hall sensor for here for also for position, EEPROM memory, flapper drive. So entire circuitry is there, and this acts as a controller itself. So FF positioner parts are yeah, feedback lever, terminal cover. This is termination is done. Electrical connections are done here. Ground terminal, air supply, pressure gauge here. Then output pressure gauges here. These are analog. These are output pressure connections are here. Air supply connections coming here. So here, like normal controller, you will get in one position itself all connections. This is a nameplate of manufacturer. So this is what positioner externally looks like. This is what as yesterday I have shown this positioner open condition and how it is standard. When manufacturers give the raw data means standard data and it is compared for the diagnostic purpose inside the uh, CPU controller. Mm. So positioner integral diagnostics, software based diagnostics and positioner integrated diagnostics. So no pneumatic data logging. View for the moment, extra user efforts, point to point communication. The permanent data logging inside this information about the complete life cycle, no extra efforts, automatic message and alarms. You can see here microprocessor base, simultaneously for a hard positioner, analog plus digital, multi drops. So these are the benefits of the wall positioner, smart wall positioner. So yesterday we have seen some diagnostic features and their benefits. Therefore, I am just skipping this. So there are so many benefits of the smart wall positioners, troubleshooting checklist, advanced diagnostic features. So and these are a few some of the few manufacturers names. This we have seen yesterday. This I have covered yesterday. So I'm going ahead with this non-contact type. Old way is contact type, linear non-contact type, rotary non-contact type. These are the road approvals for manufacturers. Now I'm just showing the how this FF positioner is commissioned in the DCS. So when you open the software of any DCS, these are screenshot of immersion Delta V DCS Delta V Explorer. normal PC Explorer, like Explorer, you can see here setup, control strategies, and you see here these are your sorry, you have areas, and in the physical network you can see the control network. In the present DCS architecture, controller is there, and in one controller there is only one controller. Assigned nodes are here, and IO cards are shown here. You can see the physical IO cards in the controller rack. Card 1 to card 7. There are 8, 7 cards are shown here, and on card 7 you can see here the card 7 you have assigned two this FF 301 tag and LY 30 means two devices are there. Means here you can see on the card 7, card 7 has a two ports. Port 1, uh, you have connected these devices. So your card 7 is a foundation Fieldbus interface card. Card 7 is foundation field. So you can see the on this port 1 you can connect directly these two devices. एक है foundation Fieldbus FF301 transmitter, and this is LY301 is a control wall. So you can go ahead. So you can see here when you see this devices here, LY detail about this you can see internal, these are the parameters inside this. I will go to the next slide. You see this the device which has been physically connected but not commissioned in the controller will appear. So you when you connect the device, decommissioning field devices, this it will be prompted, and you can see this is what noted, and moment you go to click on this, you will get the new window appears indicating the change of state the device from spare to standby. So here it goes to the from spare to the standby, and it is a processing. So then what you have to do, a new window appears for feedback device properties, and enter the necessary info such as a device tag, description, other information. Means moment you connect any new device, feedback device, automatically it's in manufacturer's tag is displayed, and only then we have to give our own tag name to the device. So this was the manufacturer's detail, and on that moment you connected, put the device tag like a PDT1, like this for just for demonstration purpose, and go ahead. So select alarm displays if you want to have alarm. Select primary control display page like this. Click OK. If nothing is there like this here, just click OK. A new window appears. Device commissioning wizard appears. Click finish. This wizard will be there, and just click finish. And moment you make a finish, the processing of the controller starts. So the whatever you have entered tag and all goes to the controller, and the this type of window you have to waiting for the device parameter to update to the database. And next will be the, you can see here the device status changes from standby. So here this device earlier nothing was there. Now you start showing the control symbols. He identified this is a control wall. And next will the device initialized by controller. Then controller initialize, standby, then initialize, and finally the device now appear on port one. You see here. Earlier it was not there. So this was a Samsung positioner, and it has appeared here. Commission device, and the icon FY underscore Samsung now appears as a commissioner device on the port one. So my point is that within the 2 3 steps you need not to remember. Only the screen helps you, and you just say finish, OK, click like this. So device has appeared here. FY Samsung. Now this triangle indicates that it is not downloaded to the card, and controller also not able to understand. So this blue triangle always is for downloading. So on the full network means you can see the hierarchy here of this arrow. This is the arrow. Same is here. same is here, same is on the IOs, same is on the controller, and same is on the control network, and same is on the physical network. So moment you download it, automatically all connected associated hardware devices, softwares updated, and this symbol goes back, normal symbol. So I will go next. So download the new filbert device FY underscore Samsung. Window given below appears. Click on S. Yes. You make it yes. You can see the status window, the confirm download. Yes. So now after the download is complete, close the window. So the message will complete, and he has creating a log while performing all this, he has checked, and it has downloaded status on each of the associated hardware system as well as software, and just close it. That's all. And you see now this for Samsung device as a previous is in the loop, and the no, uh, you will not find any error here. Earlier it was a blue triangle. Now there is no triangle here. So icon of a blue triangle disappears after all the downloading procedure is successfully completed. My point is this way the foundation filter devices are very easy for commissioning in the existing system. So by clicking on the new commission device, the various function blocks. Now this was a newly commissioned. So moment you click on this, you will get the software blocks available on this. So you can see the function blocks of the device can be accessed, transducer block, then resource blocks. So these blocks are there, right? So FF device maintenance in immersion delta V DCS. So this way, the commissioning of the foundation filbert positioner is done, and it is easy. So you can see here, this is the control foundation filbert, and as I told, this is another Samsung positioner control wall, and these are FF transmitters. So all these are FF device, field bus devices. And I told this is a junction box, field bus junction box, and the cable is a name here as a spur cable. The, it is a slightly higher quality of the cable because it is a digital signal. It should not get interface with your induced EMFs or RF signals. Therefore, you have to, because uh, that care you have to take. Therefore, slightly it is cost wise more than normal cables, we can say. So, but in the foundation field bus terminology, it is called a spur cable. Um, this is junction box. This is not a normal junction box. Normal junction box, I have shown many times a picture open, and the only termination block, and there you have to wiring. This block is nothing but it has a electronics inside, like a multiplexer, demultiplexer. Just I am just simplifying. So this is the electronic device. Mm. And the signal from here goes in the single cable, same cable, but the name is here trunk cable. Same cable, same type of a cable I am talking, not a separate cable, but the name is a trunk cable. And then uh, earlier we need a power supply adapter here, which we install in the DCS cabinet itself, in the control room system cabinet. But now the power is inbuilt in the card. The card is here H1 card, uh, and this card H1 means H1 protocol in the field bus, and for interfacing with the existing DCS, the card is used, and the name of the card is normally you call Foundation Filbus Interface Card or H1 card. Foundation Filbus Protocol Based Devices Interface Card. Hello? 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 Am I audible? Hello? Hello? Anybody? So in this slide, I am just showing the what are the accessories required for Fieldbus devices installation, especially control wall. And the control wall is shown here. Two controllers are shown. One is from Samsung, and other is from Fisher. This one. Hello, am I audible? Please, please acknowledge. Hello, 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 hello. So you can see here the device is here. To configure this device control wall, hello. हाँ मॅडम हॅलो चालू आहे ओके ठीक आहे मला जरा अॅक्नॉलेजमेंट पाहिजे होती म्हणून मी आपला बाकी काय नाही सॉरी 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 हां 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 तेच त्यामुळं म्हटलं म्हणून मी जस्ट अॅक्नॉलेजसाठी विचार ठीक आहे ओके मी कंटिन्यू करतोय ओके 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 So you can see here to configure the device selected right. This is the device. Suppose you want to configure here. Right click on the device. Moment you wire it, the device will be shown. Right click on the device and select the configure. So you will get a here window configure. In the pop-up window, you can just click on configure. So moment you configure in the resource block of the resource block, transducer blocks are three. So you can in the resource block this information is available for you. Tag name, tag description, the make is automatically coming, rose mount and this. So only you have to insert here a tag descriptions and say okay. So see here the process property offers the option of selecting the mode in which we need to operate the device. The alarm property helps us select the alarm condition required for the device. So here in the resource you have see here uh, modes, target mode, permitted, all this data is there, and you can confirm this range, alarm ranges, whether alarm is required. The hardware property specifies the hardware information of the device, related about the hardware output. Then you can see here the material properties are mentioned here in the material. In this, even identification, process, alarm, hardware, option, materials. So just under that you can get various options, and new, whatever is required for your application, you just enter that value. So select FY Samsung device, right click on the device and select configure. Mm, so moment you can then comes to the status and condition. This is the device. So you can see here, click on alarm. Moment you go on this screen, status and condition, you will get this screen, status screen. So you have here alarm on the banner, as well as detail in the alarm. It has mentioned this alarm is related to your maintenance needed now for this positioner. There are other options also, like you can see here block configuration, local overdrive. I'm not reading everything, but input failure, like this, the it is there. But in this case, it is related to maintenance needed. Then next moment you click it, this is in this block. So transducer 564 block is showing error. Same is in the resource. So sorry. So this is just for understanding the concept, how it is configured. Therefore, it is shown to you. Now I'm switching to the wireless devices, wireless positioners, so that you will get few idea about this wireless positioners. If you see your wireless here, uh, RCF, if you see wireless technology, how it is implemented. So initially, wireless was not used in the plant. So everybody has a fear. Wireless is a hazard, a health hazard. Then communication is not reliable. Getting stuck up, it will come or not. Like that. During that time, we were using mobile. So whatever mobile has a difficulty, same difficulty everybody was using in the industrial environment. So nobody was going for that, but we tried in the our pilot plant in the RCF, and you see here temperature and vibration parameter monitoring through wireless technology. So here you can see here devices are there. These are the two transmitter for wireless vibration measurement. However, this is the temperature transmitter here, wireless category. Then you can see here gateway. There are two gateways. Earlier gateway was, and I will explain you what is the why two gateways. And then we have a control also. So wireless vibration transmitters are here, wireless temperature transmitter here, and wireless gateway is here. So wireless vibration monitoring demonstration, you can see this way. You have a setup with a pump and motor. So motor, pump, found this looseness of foundation boards. So all this vibration is measured through a sensors here, vibration sensor. These are accelerometer type sensors, and through that it is connected to the through wire. It is connected, and from then transmitter in the wireless format signal goes to the DCS or workstations or your laptop. So you see in this case, wireless vibration setup. These two transmitters with four measurement points. Each transmitter has a two, so total four points of measurement at this motor side, here and here. At a pump side also you can see here and here. And these vibrations signals are taken to the DCS through the in the wireless format, and then gateway is in the either Ethernet or Modbus, or nowadays this gateway to system is also wireless to the immersion delta V DCS here. And this is a separate station. If you have PCR dedicated for wireless configuration, then there also you can configure the devices on your uh, PC here. So wireless monitoring devices integration, how it happens. So you can see here devices here, gateways, then it is on Ethernet. So Ethernet switch is there, and this Ethernet switch is for networking purpose. So in the one of the port you connect the gateway. One port will goes to the DCS controller. One two ports will go to the workstation. Like these two workstations are there. No? Workstation means PCs for a graphic display. So in this picture, you can see wireless control wall on-off type. Initially, technology developed in the wireless positioner for on-off, and now it is available for your analog type. Means you can have a 0 to 100% open close, that type of positioner in the wireless category is available. So you see this wall is a wireless wall from Fisher. This wall with this positioner is a wireless positioner, and present it is on off, and this is a normal control wall you can see with foundation fill bus positioner here. This, sorry, this is a foundation fill bus positioner, and this is a normal pneumatic positioner, and this wall is here green color you can see here, and this particular portion is highlighted here is your wireless uh, communication protocol base control wall positioner here. This one, you can, this is this. So same way here. There are two Fisher DVC 6200 is a model. This one, and Fisher 4320 is one. So this way you can connect these control wall positioners with the gateway 1410. So you can see here gateway number is changing 1410. Now here I have shown one gateway. No? Gateway is here 1410. This gateway I'm talking. Uh, this is the gateway. Mm. So what we are skipped here, this we have seen, and now we are here. So wireless control wall, and you see this wireless control wall is getting signal, or you can control from here also. So you can see this is the actual faceplate of the wire, this loop, your closed loop. If it is a for control wall operation we can say. So you can see here, because it's on off wall, you can push the button on, so wall will on. When you close, you have configured the button in the graphic for operation of the wall here. So from here you can on off, or you can through faceplate also you can control. So this is what panel on which these two workstations are there, and there you can see this operators can operate, or engineers can operate from this location. So normally wireless technology, this is a standard operate control room look, and we have also installed the wireless technology here for cooling tower for measuring the vibrations uh, here. And this way the cooling tower, the fans are there, and These are the wireless sensors, and this is wireless transmitter. I'm not going ahead with this presentation because we are discussing about the control wall. So this is not this will gives the transmitter applications or vibration applications, but up to here you understand how the wireless control wall is commissioned in the DCS and operated from the DCS. This is what my objective to show this slide. So what are the coming wireless positioner gateway serial interface card, or this is one option for this gateway. If you have a new gateway is there, advanced gateway is there, it will communicate with this system with directly on the network switch, which you have seen here. This is a network switch. So the gateway number is 1420 here. This this provides you both Ethernet as well as Modbus connectivity. However, here this gateway show only because the earlier gateway supports only Modbus. Therefore, it is connected to serial interface card of the DCS, and then the controller is a MD here. So name of a controller here, and it get processed further. So if you see here. The communication signal processing or flow of the signal, how it is coming up to the DCS, that is what it is shown here. This is a network gateway, so directly comes on this, and this is a network switch, and this is two switches, means redundant switches. Normally industry we always use redundant switches. So this is what same HART position where, means they operates on wireless HART, which has a frequency 2.4 to 2.483 gigahertz ISM band. This is the what signal processing range, and like foundation field bus, means in the general is the field bus, and in the field bus there are two prominent options are available. One is a foundation field bus. This is one group of organizations from this forum, uh, consortia, and they named the foundation field bus, and that protocol came. And another is a profibus. So profibus, profibus is another organization, another consortia, but both having almost same features. Similarly, in the wireless HART, communication protocol they launch by HART organization with HART 7 they call. HART, this is the versions comes HART 7, 7.0 is your wireless communication protocol based devices, HART 7 base. And normal wireless HART is the 6. So here in the wireless also there are two options available for the industry. One is a wireless HART, and another is equivalent standard is ISA100. ISA that is came through ISA organizations. ISA you are aware. So ISA 100 they named ISA 100 is there. Mm, what we call as ISA 100 is their wireless standard device protocol. So always it happens, but you get two options. Almost both the wireless HART as well as wireless ISA 100, both are almost nowadays compatible with different DCS with some interface devices in between. So that is not means a constraint for the user, or there is no. Earlier it was very particular. If you see the 1985 or 80s period of the automation technologies, it was totally proprietary. Suppose if you have a Honeywell DCS, then you can only select the field devices which are compatible with the Honeywell devices. So you will get only two three options, either Honeywell products or one or two. That was I'm talking about before 85 or say up to 90, year 1990. So it was a totally proprietary way of means user has no options. But after 2000, user become a main focus for any innovative protocols and all. And nowadays everything becomes universal. Even when we talk about DCS, various communication protocols, they say name the control network, VNet IP, FT, fault tolerance Ethernet, or high speed Ethernet. These are different names given by different DCS integrator for control network. Though it is a Ethernet, IEEE 802.0 like this, but they gave a different name. So that what happened, the connectors and all, everything we have to buy from that company. But now it has become a standard. Normal Ethernet means a normal Ethernet switch you can buy from the market and connect normal wires. So it is easy nowadays for the user to use, and it's a cost effective and it's available in the market. I'm talking about this Ethernet switch. Earlier it was a proprietary. Cables were proprietary. So now it is not the case. That is what. So my point is that ISA100 and Wireless Heart are two different organizations, but they provide the wireless solution for industry having similar features, and it is a compatible. Like I'm telling you, there is some slight electronics or some adapter is needed. Otherwise, it is directly connected to your systems with additional software and little bit hardware. So this way, the technology is moving, because we have seen the hard field bus and wireless. Now, really, the technology is helping a lot for the user to operate in the optimum level of the production. So this is what for today's session on wireless and control wall, or we can say wireless positioners, or filbus positioner, or hard positioner. So if you, I think this will this is I'm concluding and open for the question answers. If you have any questions, let me know. Hello, hello.
Yes, sir.
Any question?
Thank you for
Any
today's
question on?
session. It was very nice and fruitful session for the students.
Thank you.
So,
Thank you.
great.
Thank you very much. Enjoy evening. Thank you. Thank you,
Okay,
madam.
sir. We will meet tomorrow. Okay.
Okay. Thank you.
Okay, sir. Thank you.
Thank you.